Hi everyone, so today we'll solve problem 217 from Leetcode, which is contains duplicate, and it is a Leetcode easy question, and we'll go through the problem description, the approach towards solving the problem, and finally the code solution, right? And I would encourage you to kind of code it on your own in your own language of comfort, just by looking at the approach so that you're not just copying the code, right? So with that being said, let's start with the problem description. So here we're given an integer array nums, and we have to return a true if we find any value that appears at least twice in the array, or we return a false if all elements are distinct. So basically, if we have a duplicate, we return a true. If we have all distinct, we return a false. Right, so that's our task. And let's look at an example to see what we really mean by that. We'll look at the first example where we have 1, 2, 3, 1. Let's have this example here. So we see just by looking at this example that we have two ones. So our output should be true since we have a duplicate, right? And in the second example, let's say we had a 4 instead of a 1, right? We see that all of them are distinct. So our output should be false since we did not find a duplicate, right? So how can we solve this? First approach is just by using the brute force, which is for each element. We could check for every other element except itself, because obviously each element would be a repeat of itself, right? We're not counting itself, but we're checking all elements except itself, which is basically the remaining elements, and we see if we have any other element with the same value, right? And if the answer is yes, which means we have a duplicate, and we return true, right? So in this case, we start at 1, and we will look at all the other elements, which is 2, 3, and 1. And as soon as we come here, we see 1 is equal to 1, which means a duplicate. The answer is true, and we return it true, right? But let's say if we had a 4 instead of 1, then again we start at 1, and then we see at 2, 3, and 4, we exhaust this, so we know we do not have 1 in the remaining elements, right? Then we come at 2, we check for 3 and 4, we see we do not have another 2. And we repeat that for 3 and 4. We see we do not have any other elements which have a value of 3 or 4 after it. So we basically return false since we did not find a duplicate, and we exhausted all the elements in the array, right? So we checked for all elements and we did not find a duplicate, so we return a false. Now this approach is brute force because what we're doing is basically for each element, let's say we start at 1, we are checking all other elements, right? So let's say if we had 4 elements and we start at 1, we are checking 3 elements in the first run, 2 elements in the second run, and 1 element in the last run. Second last, sorry, and then we would have 0 elements in the last run, right? So basically, what I'm trying to say is for each element, we will check for n-1 elements at worst, because we're calculating the worst case time complexity, right? So for one element, the first element, we will check for n-1, which is big O of n. For the second element, we will check for n-2, which is also big O of n, and so on. And how many times do we continue this? This would be for n times because we have n elements. So we take big O of n time for n elements, which gets us to big O of n square time complexity, right? So this is the brute force, means this could be like the maximum time for this approach. And let's see how we can optimize it. One way of doing that is by trading time with space, right? So what we'll do is, instead of iterating through all the other elements for one given element, what we could do is basically store it somewhere in some data structure and check if moving forward, if we have that element stored already, right? So if we come across this one, we will see that we've already stored all elements before it, which is 1, 2, 3. And when we check if this element is already stored, the answer will be yes, and we will return a true because we have found a duplicate, right? And the data structure we use here will be a hash set. So let's say we have a hash set and we start with 1. So starting from 1, we see if 1 is present in the hash set. The answer is no, because the hash set is empty and 1 is the first element, right? Oops. Right. So we add 1. Then we go to 2 and we see if 2 is present in the hash set. The answer is no, so we add 2. We check for 3. Is 3 present? Nope. We add 3. Then we come across 1. We check if 1 is present. The answer is yes. We have stored 1 already. So we have a duplicate and we return a true, right? But let's say instead of this 1, we had a 4 here, right? So when we come across this 3, we check, do we have a 3? Nope. We add the 3 here. Then we come at 4, which is here. And we see is 4 present? We say nope. We add a 4. And we have basically exhausted all the elements in the array. There's no more element after it, so we know we cannot iterate any further, right? So after reaching 4, we've exhausted all elements, and since we did not find a duplicate, we return a false because there are no duplicates in the array, right? Now let's test this finally with the last example to make sure that we have a correct approach. I'm just going to remove all of this. So let's say we have this example 3, right? And we will have a hash set, start from 1, and we will see, is 1 present in the hash set? The answer is no, because the hash set is empty, right? So we add this element 1, and then we go on to the second one, which is also a 1. So we check, is 1 present? The answer is yes, because we've already inserted a single 1. So as soon as we come across an element that is already present, we immediately return a true, because we don't even need to check for all other duplicates, because we just need to return a true or a false based on if we have duplicates. So the minute we find one duplicate, we return a true, right? So basically we would return a true and then we would terminate. And if we do not have a duplicate, we would have to iterate through all the elements and check if they're present in the hash set, right? So basically, if the condition is false or if the output is false, we would have to check for all elements in the array, which would be big O of n time, because we have n elements in the array, right? So our time complexity would be big O of n. And for each element, remember we check in the hash set, but checking in the hash set is big O of 1 time. So for each element, even if we do check if they're present in the hash set, the time complexity is big O of 1 for n times, which overall leads to the final time complexity as big O of n, right? But we are trading off time with space because we are storing all these elements in this hash set, right? So our space complexity would also be big O of n because worst case, let's say if the answer or the output is false, then we would end up adding all n elements in this hash set, right? For example, in the second example, we have 1, 2, 3, 4, right? So for this example, I'll draw it here. We will start at 1, we see 1 is not there. We'll come at 2, we see 2 is not there, 3 is not there, and 4 is not there. And then we've iterated through all the elements. So we can return a false because there's no duplicates, right? But if you see, we have stored all n elements to check if we have any duplicate element, right? So the space complexity, worst case, is big O of n. And this is our optimal solution, which is basically time and space, both are big O of n. And that's it. Now let's go to the coding solution. Right, so this is the coding solution, and I've already written it out so we don't waste time in coding it. I'll just explain this line by line for those who are not familiar with Python. So we have a set, which we have defined by this keyword, and we define S as a set in Python, right? And what we're doing is we're iterating through all the elements in nums, and we're checking for each element, which is denoted by I, is that element present in the set, which we have defined as S, right? So we are checking if the element I is present in the set S. If it is, we know we've found a duplicate, and we don't even need to check all other elements. We can immediately return a true. But if not, we need to add that element to the set, because remember, for every other element, we need to check if we had previously encountered that value, right? So we add it in the set if we did not find a duplicate for that value or element, right? And once we've iterated through all the elements in the nums array, we know that we haven't found a duplicate because we did not execute this. So if we did not return a true already, we will basically come out of the loop after going through all the elements and then finally return a false, denoting that we did not find a duplicate. Right, so that's it. The time and space is big O of n for the solution. And if you found this video helpful, please like and subscribe to support the channel. And you can also contribute on my Patreon link, which is in the description and is completely optional. So that's it for today, and see you next time. Bye-bye.